Hi, this is the GCE-XFS test team, and this is our final video presentation for cloud computing EC528. The team consists of myself, Maha Ashur,
经理
Jim Pengshi,
and Gordon Wallace.
GCE-XFS Tests is an open source project that was developed in response to the need for fast and cost-effective cloud-based regression testing for Linux file system developers and repository maintainers. The project offers a way to quickly and easily run a suite of tests using Google Cloud Engine. The user runs the tests on virtual machines and then receives an email back with the results. The tests are monitored using the Lightweight Test Manager, or the LTM, which also parallelizes the tests, allowing for multiple tests to be run at once. Our goal is to extend the existing project to enable two new features. The first feature is repository monitoring, with the goal of automatically launching tests every time there is a new commit. The second feature enables us to find a bug in a given source tree using bisection testing. The way we chose to attack this problem is by creating what we call the build server. At the moment, a user of GCE-XFS tests has to build a kernel on their computer before they can launch a test. Using the build server, they can build the kernel in the cloud from a commit, branch, or tag for a given repository. This build server has to be larger than the existing LTM in order to execute the builds. Our minimum viable product is creating the build server itself, as well as modifying the LTM to support this new build server. Specifically, the LTM should be able to launch the build server. The build server should then build the kernel from a commit, branch, or tag passed as a command line argument by the user. The build server should then notify the LTM that it has completed its work, and then the LTM should optionally shut down the build server if it doesn't need it anymore and launch the tests. Now we present the current architecture versus the proposed architecture. Under the current architecture, the user launches a test using gce-xfstests LTM. That launches the LTM, which then takes the kernel that has already been built on the user's computer and puts it into Google Cloud Storage. The LTM then launches one or more test VMs using the test kernel from Google Cloud Storage. When the tests are complete, the LTM then puts together a report and emails it to the user. Our proposed architecture adds the components highlighted in the yellow oval. When the user requests a test, the LTM, instead of directly launching the tests, will first forward the request to the build server. The build server will clone or update the necessary repository before beginning the build. Once the build is complete, it will upload the kernel into Google Cloud Storage and then notify the LTM that it has completed the work. The LTM can then launch the tests as before.
For our system components, we use Google Cloud to run all of our virtual machines for the kernel building and testing and for storing the project files. And we will implement a build server to build kernels from given source code. And we also have an LTM server to manage testing and the build server and to monitor the virtual machines and the repositories. We will use Flask, which is a lightweight web framework that allows us to establish simple web services for communicating between the VMs. We decided to implement the build server as a standalone feature, which makes it easier to be used independently and to be integrated into the existing project. We will use the Flask for the build server, which allows code reuse. However, we will implement asynchronous communication using two synchronous endpoints between the servers. We also decided to use regular persistent disk or PD as our repository cache because to clone a repository takes a lot of time. So we decided to just cache it into a PD, and the PD will not be deleted even if the build server is shut down. In Sprint 1, we met our mentor. We did some research about GCE, LTM, and existing XFS test systems. And we also run some basic tests, GCE-XFS test smoke or full, to get familiar with the testing process. And we also launched an LTM server and use it to run the same test as before. You can see below the burn down chart which tracks our progress. In Sprint 2, we added some build tools to the Debian image, which is used by the LTM and the build server so that the build server can build kernels. We also used the Flask to communicate between two regular GCE machines. We were able to launch and kill a build server that does nothing. We also wrote a wrapper for SCP to make our testing easier.
In this video, we show you one of the first steps we took towards achieving our MVP, namely, to launch and shut down a build server. gce-xfstests-ls lists any instances or VMs that are currently running. As you can see, there are no such instances. Next, we do gce-xfstests launch build server. This step takes a few seconds. As you can see now, the build server has launched. If we do gce-xfstests-ls, we should now see that there is a new instance. Finally, we have to shut down the build server. For this, we do gce-xfstests-rm instances. This deletes the instance. Now, if we run gce-xfstests-ls again, we should see that the instance is shutting down.
Here is the sprint 3. So in previous sprint, we have a build server, but it can do nothing. In this sprint, we enabled the build server to build a kernel. And we also enabled the build server can build a kernel specified by the user from a git commit or branch or tag. And for the communication process, we began to implement the two-way communication between the LTM and the build server with Flask.
In this video, we demonstrate the second step towards achieving our MVP, which was developing a standalone build server. As before, there are no instances currently running. However, if we do gce-xfstests-ls disks, we'll see that there is a regular persistent disk. That is our repository cache. Now, when we launch the build server, we expect that it will attach this disk and mount the file system. The persistent disk we are using in this demo already has cached repositories on it. So just like before, the build server launches. Now we can do gce-xfstests-ls disks again, and we'll see that there are two disks, the build server's disk as well as the repository cache. Now if we check our Google Cloud Storage bucket, we'll find that there's no kernel in it at the moment. Our next step is to execute the build itself. For this, we run gce-xfstests build, and then we specify the commit using --commit. This can be a commit, a tag, or a branch. And then we do --config to specify the def-config file for the build. The user specifies a local path, however, the file gets copied to the GCS bucket so it can be used for the build. You can see here that the build request has succeeded. However, you'll notice there's already a repository URL in the request. That repository was already specified by the user in the gce-xfstests-config file. This simplifies the build command since you only have to pass in the commit ID and the path of the def-config. Next, we can SSH into the build server to see if the persistent disk attached correctly. We can try lsblk, and we can see that the disk is properly attached and that the file system is mounted. If we take a look at the contents of repositories, we'll see that there are actually two repositories already in there. The URL of the repository is hashed so that the user can have multiple repositories with the same name. Now we wait for the build. For the sake of time, we skip forward a little bit in this video. As you can see, the kernel is now in the GCS bucket. Finally, we shut down the build server. Our goal is to keep the persistent disk around even after we shut down the build server. That way it can function as a cache. If we do gce-xfstests-ls, we will see that the build server is shutting down. If we do gce-xfstests-ls disks, we will see that the build server's main disk is now deleted, but that the repository cache is still there.
Let's move to the Sprint 4. So in Sprint 3, we have a build server which can build the kernel. And in this sprint, we enable the LTM server to launch the build server, which is the main process of our project. And as we wrote more and more codes, it's necessary to add some error handling, log informations, and test our code. Also, we keep on implemented the two-way communication between these two servers with Flask. So in Sprint 5, we want to improve the build time for the build server. And as we had said before, we added a persistence disk to serve as a repository cache, which will store the Git tree. And we enabled the LTM to shut down the build server, which is the final process of the build server. And we created a prototype of the repository monitoring feature, which we prepared for the bisection function, and more tests of our code. After the Sprint 5, here is the final push. Previously, we manually called some function to enable the communication between these two servers at some key moments. But in this sprint, we automate this process. Now, the communication process can run smoothly. Also, in this final push, we submitted some patches to Mentor for the review process.
In this video, we demonstrate the last stage of our MVP, which is to launch tests using the LTM by first requesting a kernel build using the build server. In this case, the LTM is already running. If we want to launch a simple smoke test, we would normally do gce-xfstests-LTM smoke. However, now we modify the command to include the -- commit option and the -- config option. As you can see, the LTM launches the build server. If we do gce-xfstests-ls, we will see that there's now a second instance that represents the build server. Now we wait for the build. As before, we skip forward a little bit in this video. You can now see that the kernel is in the GCS bucket. If we do gce-xfstests-ls, we will now see that there's a third instance. This instance represents the test VM. And if we do gce-xfstests-ls one more time, we will see that the LTM has now shut down the build server. This last step is optional and depends on whether we want to keep the build server around for future builds.
Given more time on this project, there are some additional features we'd add. We'd like to further optimize the size of the build server in terms of CPU and RAM, and the size and type of persistent disk given the trade-off between cost and build time. We'd also like to allow users to have build results emailed to them automatically using the SendMail service, implement repository monitoring so that builds can happen automatically when a new commit is made, and create a bug-finding feature that uses Git bisection testing. At the end of the project, there are still some unanswered questions we'd address if we had more time. For the bug-finding feature I just mentioned, we'd need a way to ignore bugs the user isn't looking for, and we didn't get to figure out how we'd do that. There was also the question of whether we could further shrink the LTM and make migration to Python 3 easier by eliminating Flask from our design and using an alternative for communications, such as curl. Kernel development currently doesn't employ a lot of continuous integration. The development process is very hierarchical, and as a result, builds are released periodically rather than continuously. gce-xfstests is a step towards a more continuous development process with its suite of tests and the ability to run them on a variety of configurations with simple commands. Our work on the build server has the potential to further move the kernel development process towards continuous integration, as the build server could make it easy to create and test builds remotely, and to do so automatically if repository monitoring is implemented. We faced a number of challenges as we built on the existing gce-xfs test system, many of which related to lack of experience in this area of work. Some of us weren't familiar with Linux, and one of us didn't even understand what a kernel was at the start of the project. For some of us, this was our first time using Google Cloud as well. One of our most persistent challenges throughout the semester was establishing asynchronous communication between the build server and LTM due to challenges in choosing the best method, figuring out authentication, and properly understanding the existing system we were building off of. As mentioned, we successfully implemented this communication using Flask. Finally, we were unable to use the sendmail service because we couldn't get it to work with our BU email accounts. Working on this project for a semester was very educational for all of us. Creating the build server required learning a lot of shell scripting language. Establishing communications through Flask had us learn about web services, sending messages between servers, and parsing those messages. Significantly, we became much more familiar with Git, since this project took us well beyond what we'd used it for in the past. We had to learn to rewrite Git history in order to present our development process coherently. We also learned how to automate Git features in Python using the Git Python library. With that, we'd like to conclude and thank you for watching. We'd also like to thank our professors Oran Krieger and Peter Desnoyers and our mentor Ted So.